Hi everyone, I'm Christina and welcome to the next video in our A-level trigonometry series. So in this video we're looking at solving trigonometric equations and this is part 1. So our objectives for this video are to identify the structure of a trigonometric equation and solve with an appropriate method. We're also using exact trigonometric values to solve these equations, so have a look at the previous video on that. And we want to use properties of trigonometric graphs to find all solutions within a given interval. In this video, our examples will have an interval of 0 to 2 pi. So we want all the solutions within that interval. So starting with our first example here, we want to solve the equation sine x equals a half in the interval of 0 to 2 pi. This is quite a basic example. So what we're going to do first is apply inverse of sine to both sides. So that means that we want x equal to sine inverse of sine of a half. From our exact trig values, we recall that that is equal to pi over 6. So our first solution is pi over 6. If we have a look at our graph, we want all the solutions for sine x equal to a half within our interval. So the first one here is pi over 6, but we can see we have a second solution here, which from the symmetry of our sine graph is pi minus pi over 6. Okay. So our second solution there is pi minus pi over 6. And our final two solutions are pi over 6, and pi minus pi over 6 is 5 pi over 6. And these are the solutions within 0 to 2 pi. Just make a note here that there are infinitely many solutions of the equation sine x equals a half, but we are only interested in the solutions within the given interval. So in the next video, we'll look at some examples where the solutions aren't restricted to a particular interval. Okay, but for now, we're just looking at the solutions between 0 and 2 pi. So let's try our second example. So here we want to solve the equation 2 sine theta equals 3 cos theta. So from our first video, recall that sine theta over cos theta equals tan theta. We can rearrange that to give sine theta is equal to cos theta tan theta. So we can rewrite the equation we want to solve as 2 cos theta tan theta equal to 3 cos theta. A common method here would be to divide both sides by cos theta. But please note that we are assuming cos theta is not equal to 0 if we do that. So we're going to have to check that at the end. But for now, let's divide both sides by cos theta. So what do we get from doing that? On the left-hand side, we just get 2 tan theta. On the right, we just get 3. And so rearranging a little bit, we get tan theta is equal to 3 over 2. And so theta will be equal to the inverse of tan of 3 over 2. And that's our first solution. So if we then have a look at the graph, which I've sketched here, and we want the inverse of tan of 3 over 2, so 3 over 2 might be somewhere there. And we want all the solutions within 0 to 2 pi there. So our first one, let me redraw that. So our first one is going to be here, tan to the minus 1, 3 over 2. And you can compute that in your calculator, but I don't want to round, so I'm just going to leave it as I've written it. And so this is our first solution here in radians, but we can see that there is one more solution here within our interval. And that's just equal to pi plus tan to the minus 1, 3 over 2. So there is another one here, but of course that is not within our interval. That goes past 2 pi, so we don't include that one. So we only have two solutions here, tan to the minus 1, 3 over 2, and pi plus tan to the minus 1, 3 over 2. So now let's go back to checking our values of cos. So we assume that cos theta was not equal to x to get our two solutions here. But what if cos theta was equal to 0? So that would give values of theta, again, recall your exactric values, of pi over 2 and 3 pi over 2. Now, if we plug those values into our original equation, 2 sine of pi over 2 is 2 times 1. But then, of course, 3 cos pi over 2 is 0. So if the left-hand side is 2, but then the right-hand side is 0, well, those aren't equal. So that doesn't satisfy our equation. And the same thing happens for theta as 3 pi over 2. Well, sine of 3 pi over 2 is minus 1. So the left-hand side is minus 2. The right-hand side is 0. They are not equal. So again, that does not satisfy our equation. So in fact, cos theta equals 0 is not a solution, is not part of our solution. So we haven't lost any solutions as we've worked this out. So we don't have to worry about that. But it's important for us to check this to make sure that we have the complete solutions in our interval. So for our next example, example 3, we're solving the equation 2 sine squared theta is equal to cos theta plus 1 in the interval 0 to 2 pi. So again, recall sine squared theta plus cos squared theta is equal to 1. What would be good for us to do is to rearrange this to make sine squared theta the subject. So we're doing 1 minus cos squared theta. And that will be useful for us because now we can substitute in this expression for sine squared theta into our original equation that we're trying to solve here. And so then we can get an expression all in terms of cos. So let's continue with that. We'll have 2 sine squared theta, so 2 of 1 minus cos squared theta equal to cos theta plus 1. And so let's multiply out the left-hand side. So we get 2 minus 2 cos squared theta equal to cos theta plus 1. So let's rearrange a little bit here. Let's get everything to one side. So we're going to minus cos theta to bring it to the left and minus 1 to bring that to the left. And then simplify a little bit. So we get 2 cos squared theta minus cos theta plus 2 minus 1 plus 1 equals 0. And then we can just multiply everything on the left-hand side by minus 1, or you could have brought it all to the other side and then equated it to 0. That's fine too, but I'm just going to multiply each term by minus 1, and so I get 2 cos squared theta plus cos theta minus 1 equals 0. Okay, so let's try and look at the structure of this expression, 2 cos squared theta plus cos theta minus 1. It might be easier to see if we let cos theta equals u. So if we do that, then we get 2u squared plus u minus 1 equals 0. And so now we have the form of a quadratic equation. Okay, so this is a quadratic we can solve. And let's try factorizing it first. So 2u brackets u. We need two numbers to multiply to give minus 1 and add together to give 1. But of course, we have to take into account that our a is greater than 1 here. So what's going to work for that is if we plug in a positive 1 in that bracket, and then we have a negative 1 here. Okay, so if you were to multiply that out, you could see that, in fact, 2u squared plus u minus 1 does factorize to give 2u minus 1 and u plus 1. So our two solutions here for u are u equals 1 over 2 and u equals minus 1. But remember that u is cos theta. So in fact, cos theta equals a half and cos theta equals minus 1. So now we're solving cos theta equals a half and cos theta equals minus 1 for values of theta between 0 and 2 pi. Okay, so again, theta, for cos theta equals a half, theta is going to be equal to the inverse cos of 1/2. And from our exact trig values, that is pi over 3 there. And then for cos theta equals minus 1 between 0 and 2 pi, our solution for that is pi. So again, let's have a look at our graph. So I've sketched it there. We're only concerned the values between 0 and 2 pi there. But we have cos theta is a half. So that's going to be there. A half. And then for cos theta equal to, equal to minus 1. Let me redraw that. So equal to minus 1, which is there. Okay, and we want all the solutions within our interval. So for cos theta equal to minus 1, we only have one solution, which is our pi. So that's our only solution for that one. And then for cos theta equals a half, so yes, we have this solution here of pi over 3, but we have another solution within 0 and 2 pi, which is right here. Okay, and again, from the symmetry of the graph, we're able to work that out because that's going to be 2 pi minus pi over 3. So if I shade it in a little bit, you might be able to see the symmetry a little bit better. Okay. So that's pi over 3. Well, then this is also going to be pi over 3. And so what's this point here that gives us our next solution, it's going to be 2 pi minus pi over 3. Okay, so for cos theta equals a half, theta equals pi over 3, but theta also equals 2 pi minus pi over 3. And if we compute that, that just gives us 5 pi over 3. So let me write all the solutions out now. All the solutions for 2 sine squared theta equals cos theta plus 1 within the interval of 0 to 2 pi are pi over 3, 5 pi over 3, and pi. Okay, so in the next video, we're going to go through a few more examples and also look at equations that do not have the restriction of a particular interval.